Hello everyone, welcome back to the channel. Today, as part of my training, I'm going to solve this old case called Lumberjack. This is an old one back in 2021 from the FMWC Open, which was the old designation of the Excel World Championship. Let's see what we have. So, you have recently acquired a piece of forest land in the fictional country of Microlandia. You obtained a permission to cut the forest and build a lumber mill in the middle of the forest. Exact map is provided on the map tab. Forest contains 5 different species of trees. Each tree takes a separate cell. Okay. Center column brown and do not contain represent a road. Okay. Cutting each tree provides a different amount of processed wood products, while a pine gives you 10 cubic meters, denoted m cube of final products. A palm gives only 5. Okay. Cutting costs are different. On the other hand, after the trees are shipped to the mill, processing costs are the same for all of them. $10. Distance and transportation cost. Additionally, the further tree is from the road, the more expensive will be the transportation. This is measured in cells, going horizontally or vertically. For a tree located in cell H8, the distance of the road is 1 unit. Okay, as we don't measure diagonally. Okay, sales price. The main variable in this case is the sales price. The market price of wood is very volatile in dollars per cube meter of pine. Okay, but I don't have the symbols actually. Okay, I can see them here in the formula bar, but unfortunately they're not showing up here. Okay, I think I'm going to call this right away trees, volumes. I'm assuming I'm going to use all those variables, cut cost, trust cost, sales price, percentage, and processing cost. Okay, I'm giving the names to the cells in order to avoid then pointing absolute references, which is not a good idea. Okay, in the map we have this layout. Okay, so basically they're saying that distance is measured only vertically, horizontally. So they said H9 is going to be 2 cells distant from the road. So what I'm going to do is to copy this right away, to call this map distance. I think I'm going to do like this. Basically, what I want to have is the distance from the road in each and every cell of the map where applicable. So I'm going to use a quick trick in order to do that. Otherwise, I would have to define when the road is cell by cell and then calculate different distances, which is not a good idea. Uh, Basically, what I'm going to say is this: the distance is always 1 plus the minimum of everything that is one cell near, going up, down, left, and right, not diagonally. And then I'm basically going to copy this wherever I can. I need to pay attention to the edges of the map. And then I'm also going to enable the iterative calculations. Okay. Okay. Yes, there are circular references. I know. I need to enable them. I need to say formulas, enable. Okay. And as you can see, this is going to update. So it says this is 0 distance, this is 1. Here the closest distance is this. So it's going to say 1 plus 1, and so adding up to every cell step by step. here, basically, I'm going to say 1 plus minimum of this, this, and this. So I need to avoid the up direction. Here I'm going to say minimum of this. Interesting. 1 plus minimum of this and this only. Here I'm going to say 1 plus minimum of this, this, and this. Same applies here. Okay, not going into the Z direction. Okay, 1 plus minimum of this and this. 1 plus minimum of this, this, and this. So I'm not going down here. Okay, 1 plus minimum of this and this. 1 plus minimum of this, this, and this. Okay, and 1 plus minimum of this and this. Fantastic. Let's see if this works. So 1, 2, 3. Yes, I think so. 10 here because we have the one step in a diagonal direction. Uh, okay, 11. I think I'm going to paste values here in order to. Something went wrong for some reason. Okay, so I can also disable the circle references. How many units of each tree are there in the forest? Okay, this is an easy one. I'm assuming the unit is populated, so this is, let's call first of all this map. Distances. So this is a countifs in map of this. Total volume in cube meters of each type of tree. This is again the countifs, but times x lookup of these trees and volumes. I hope so. Let's see if this checks out. 259,139. Okay, 259. I think it's quite right. How far are the following cells located from the road? Okay, in this case, this is an easy task because I already calculated the distances. So what I'm basically going to say is to leverage the indirect function in order to point to the corresponding cell given the address we are provided as the dataset for this level. So I'm just going to say indirect direct of up this and this. Okay, this sums up to 83. Let's check whether this is correct or not. Yes, 173, 263, 73, 263. Okay. Level 3. What is the total cost of cutting and transporting the trees located in the following cells? Okay. So, maybe this is a good idea to leverage the one cell formula approach. So I'm going to say let of cutting and transporting. So first of all, I need to know what is the tree there. So tree will be indirect of map. Uh, Map and this. Let's see if this works. Okay. So this was just to check the formula is working properly. The cutting and transporting. So cut XLOOKUP 3 into trees, cut costs, TRASP. How does this work? So transportation cost, dollars per tree per cell, okay. So basically this is an X lookup. Transportation cost times indirect. This time I want the map list. Yes. That's where the tree is located. Following cells. I think I'm good because the cut cost is a unitary cost. Okay. So I just need to output the cut plus, sorry, the cut plus trasp. See if this is working. Yes. Let's check 30, 42, 14. The sum is 320. 14, the sum is 320. Okay, that's right. Level 4, what total profit will the business generate after the trees are cut if the selling price of 1 cubic meter of pine is X? Assume that all the trees will be cut, even if cutting a specific tree brings losses to the company. Okay. I might still leverage the one formula solution. So we'll to add the processing cost. First of all, let's copy this here. Okay, so I need to say that processing cost is 10, as always. Pa, pa, pa. I need to say that this is map. Okay, so what I'm saying is basically don't take just the reference to one cell, but take the entire map. So we'll apply dynamically to all the trees in the map, but not only the trees, so we'll need to manage the road basically. Cut is X lookup of this. We'll probably need to add a 0 here if this is going to go in an error. Transportation costs, same. And here I think I will just need to say distances. Processing is 10. Total profit. Okay. What are the costs associated? We have the cut cost, transportation, and processing. So I can say that tot cost is cut plus trasp plus processing. I think I will need to sum here, sum here, and I will need to say that let's do like this. I don't trust that 10 processing cost. Okay. Let's see what we have like this. Dot cost. Okay, fantastic. So for some reason this is not working. I will need to find out why. Okay, so the cut cost is working. The transportation cost is not working. I might need to drop any ferro here. Okay. Okay. Basically, I think that while for the cut cost, having a zero here in X lookup, so when X lookupping the road gives an basically useless output in order to go into the trees table. When doing this, basically the times distances was resulting in an error because that was not managed through the XLOOKUP. So I'm just throwing in a error here and saying that if it goes to error, it's zero because probably I'm taking a cell without any kind of tree. Processing cost is fine because now my total cost is correctly calculated. So unit cell price will be this. Tot revenues will be mm, 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 unit sell price times uh, times X lookup three trees sales price percentage. So basically for every tree I'm going to X look up the sales price percentage, multiply for the unit sell price, to say zero. This is not working. And I'm going to sum everything, I think. And so my dot profit equals dot revenues and dot cost. I'm interested in dot profit. Okay, something is not working. This is a minus. Okay, this is not a good result. Uh, 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 uh. Let's try for the example. So the cut cost, I'm going to sum everything. Then transportation, okay. Then processing, okay. This is basically in terms of revenues giving me 11 times percentage price percentage. This is the output of this. It's clearly too low. Ah, okay, this was the price for 1 cube meter, so I need to multiply also for the volume. And the volume will be the X lookup of 3 into trees, volumes 0. Okay, it's probably much more reasonable. Okay, but it's not checking out for some reason. Are there any other costs which go with the volume? Yes, the processing cost actually is linked to the volume. So I need to multiply also here like this. Okay, this time checks out. So let's copy this down to 2662. The sum is 624150. 624150 2662 8226. Okay, seems right to me. Level 5, assume that the business now carefully calculates unique economics and will not cut a tree that does not bring profit. How many trees will not be cut at different price levels for 1 cubic meter of pine. Okay, so basically I need to know how many unitary profits are there for the entire map, and I will not going to cut those trees. So let's copy this down. Pa, 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 pa. Okay. I think I will not need to sum everything because I'm just interested in calculating the unitary values. Pa, 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 pa. Unit revenues. Unit profit. Unit profit. Okay, so basically what is happening is that uh, the formula is giving as an output, imagine the entire uh, map, so a 24 times 24 big grid of values, which should be the unitary profits of each single tree. I'm going to say if unit profit less or equal than 0, then 1, otherwise 0, because I'm interested in the trees with a negative unitary profit. And I'm going to sum them, basically. I think that's pretty much it. Uh, 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 uh. Actually, this is the economics. Okay. 460 cells are giving me a negative or 0 profit. I need to get rid of the road. So what I'm going to say is how many cells are in the road. Let's see. Basically 53 plus 1 for the home. And so I'm going to say that 54 is my go-to number. Okay. Let's copy this down. Let's copy the values and let's see if this checks out. 571, the sum is 2639 and the sum is 2639. Okay, great. I think I will stop here, otherwise the video will be too long to tackle level 6, which is very, very, very complex. So thanks a lot for watching and we'll see you in the next video. Thanks, bye.